All right, so let's go back here. So remember, here's our straight line form. We have K in one column, we have temperature in the other column. We want to transform it though because 1 over T is going to be our input, that's going to be our X, and our output is going to be ln K. So we want to plot 1 over T on our X-axis and ln K on our Y-axis, and then this is going to be our slope, negative E over R, activation energy over R, which is in that 8.31 joules per mole Kelvin form. Here we can look at it again, just so we can remember. So we're going to plot again. Remember, our temperature needs to be in Kelvin too. So it says Kelvin to the -1. So let's give it a shot. All right, let's go to our spreadsheet. Here we go. All right, so our temperature is in Celsius, and our rate constant is not in natural log form. So we're going to transform both those using what we did the other day. So we're going to do temperature as 1 over Kelvin. So to do that, we're going to say equals, and then we're going to say 1 divided by, let's put in parentheses, this value. We got to put it into Kelvin, so we're going to take our 7 Celsius temperature, add 273, and then we're going to press enter. Now, if we drag that down, let's see, does that, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm doing it below because I did it over here and it didn't work for some reason. So this is actually my second attempt. So hopefully it plots it on the right axis this time. All right, so we're going to do natural log of K, and we're going to do equals this value there, rate constant, and we're going to drag that down. Okay. This doesn't look like it did the natural log. Oh, it did not. Just to repeat those numbers. Equals natural log of, okay, that's our natural log. Okay, so now let's try to plot these against each other. We should do a scatter plot because we're trying to get the line of best fit. Yeah, okay, there's our temperature. Oh, cool, look, it looks like a straight line. We can mess around with these axes, but I'm not going to bother because we just want to get the trend line anyway. So we're going to customize it. We're going to go to series. We're going to add our trend line. And it's linear. Oh, beautiful linear trend line. That's what happens when you get data from the book. Show R squared, why not? Should look at that. 1, perfect R squared. So again, that means our trend line matches perfectly with all our points. It goes right through them all. 1 is the highest R squared value you can have. We want to look at the equation though. Okay, so there's our equation. All right. So here is our slope, negative 12,174. And if we divide that, we'll make that positive because it's activation energy. It's going to be a negative slope, but we're just going to take the absolute value. So here, let's see if we've got that number. Negative 12,174. Okay, and I'm going to go up here. We're going to say equals that number, and let's divide it. Let's just make it positive. 12,174 divided by 8.31, which is R. So that is our activation energy in joules for this reaction. So there you go. Hopefully that was a good refresher from some of the stuff that we did with the integrated rate law.